Welcome back to Tech With Hos. Today we're solving LeetCode 1029 GCT scheduling. This is one of those interview problems that looks complicated at first because there are so many possible ways to assign people to cities. But once you discover the key inside, the solution becomes surprisingly elegant. By the end of this video, you'll understand not only how to solve the problem, but more importantly, how to think like an interviewer. Once you think, let's get started. Imagine you are responsible for booking flights for a company. You have two employees, and exactly half must fly to city A, while the other half must fly to city B. Every employee has a different cost for each city. The challenge: find the minimum total cost. Most candidates immediately start thinking about trying every possible combination, but here's the twist: the optimal solution doesn't require DP or dynamic programming, backtracking, or any advanced technique. A simple greedy strategy solves it beautifully. Let's see why. The problem asks a company is planning to an interview, which means given her a cost of there is a cost of A to B cost of, which means the entry looks like the cost A cost and B cost, as we see in this one. Then where a cost A is the cost of sending a person to city A, and B cost is the cost of sending a person to city B. So our task is to send exactly n people to city A, send exactly n people to city B, and we minimize the total cost, reaching the minimum cost to fly every person to city A, such that n people arrive in each city. So let's look an example for this one. There is a costs where each person 10, 20, 30, 200, 450, 30, 20. So the answer became 110. And how? The first person goes to CTA for a cost of 10. The second one also goes to CTA for a cost of 30. The third goes to CTB for the cost of 50. And the fourth person goes to CTB for a cost of 20. When we add it to is becomes 110 to half of the people interviewing in each city. So it's the minimal and efficient solution. But how do we arrive at the efficiently? The first thought that comes to your mind is a brute force solution. The most obvious idea is for every person, send them to A or send them to B. Then check whether exactly half went to a city, finally calculate the total cost and keep the minimum. The problem, the number of possibility grows exponentially, which means let's see this problem as exponentially because it grows. Trying combination that not every person have two choices, as we said. So for every person, we have two choices, and each of the n people can go to city A or to city B. The total possibility becomes to the power of n possibilities, which means the exponential time. Oh, it's like simply too slow for the solution. So we need a smarter approach. So for a smarter approach, we use like instead of deciding directly where everyone should go, let's think differently. So the key insight is where the magic happens. Instead of deciding directly where everyone should go, let's think. So now let's ask simple question. What is the cost difference if I move this person C2B to city A? Oh, that's right. So the difference is A minus B or cost of A minus cost of B. Or we can say the cost B cost minus A cost is the price of moving one person to B. Yeah, we got it. So choose who moves. We only decide which N people switch to CTB. So our cost becomes we need to sort it by our cost. So our cost become cost of I is cost of B of cost of I minus a cost of I, which means the cost of the last index and the first index, which means the first index and the zero index. We can calculate it by that. So After we sorted, the greedy happens as this strategy for every person, cost of A minus cost of B. Then sort everyone by this value. After sorting, people at the beginning strongly prefer CTA. So people at the end strongly prefer CTB. So, or we can say at first we can do people prefer CTB and the remaining people prefer CTA. So that's the strong ultimately gives out the optimal assignment, then we can do it. Then we can get it the optimal solution after we track within a total. So let's see by the implementation side. Always I use Python for this problem also. So enjoy watching my video. It's very efficient. So be careful, enjoy my video and see it attentively. So it's simple. As we said, firstly, we sort it. So sort using lambda function is equals to lambda. Uh, so I said C and C at index 0 minus C at index 1. Then after sorting, I use calculate the n, the length. So it's used for the for loop lane of Costas. So after Costas, because we use half of the people goes to the one city and the half of must be goes to the other city. So I used over two, and after this one, I I initial the to total equals to deal to track the solution. So it's become total. After this, I use for loop for I in range of n. It needs to go to the CTA because we calculate from the difference from CTA to CT be and sorted. So the first people will prefer to CTA. So for that matter, total total plus is equals to costs of I at 0 index. And after this one, the rest of after n loop, the rest are for I in range of so n comma 2 times n, because we have 2n people, so total 2n choices. I'm sorry. So cost is it must be cost is. I'm sorry for this one also. Cost is at I and at 1 index. So after this, we just have to return the total. It's enough. So let's check it. Yeah, accepted. Let's submit it. Yeah, 100% efficient bit. So thank you for watching my video. We'll see you on the next video. Thanks. And if you find this explanation helpful, make sure to like the video, subscribe to the channel, and share it with your friends. Also comment, did you initially think this was a dynamic programming problem as me, and did you spot the greedy insights right away? So thank you for this. This is Tech With Hos, helping you become a better problem solver one LeetCode problem at a time. Thanks for watching, and I'll see you in the next video.